Earlier, we looked at how to declare Dublin core in HTML in a meta tag, right? HTML and meta tags are human readable, but they're not really intended for humans, right? HTML is intended to be read by your web browser or by other pieces of software. Now, HTML is not complicated, so it is in fact human readable if you know what you're looking at, but it's not really meant for humans. It's meant to be read by software, and for something to be interpreted by software, everything has to be very precisely defined, right? Humans are okay generally with the ambiguity of natural languages, right? The fact that the word table means different things to different people in different contexts, for example, right? Now, naturally, the ambiguity of natural language leads to some misunderstandings. Lots of good comedy is based on, linguistic misunderstandings, to be sure, but mostly human beings cope okay with the fact that the language we speak is ambiguous, right? Because the context of a word helps you to interpret it, right? The rest of the sentence around a word, the conversation you're having, the context, puts the words that you're using in context and helps you interpret the fact that you mean a table as a piece of furniture instead of a grid of numbers on a piece of paper. Human brains are good at disambiguating things. For whatever evolutionary reason, we're just hardwired that way, right? Computers, not so much, right? So for metadata to be interpreted by software, all the terms in a vocabulary must be very precisely defined in a encoding scheme of some sort, right? So the instructions for defining terms have to be somewhere that a computer can look at them and get those definitions, get that semantics. Enter namespaces, right? A namespace is not a physical space. It's a conceptual space. It's a mental space or an electronic space, right? That space contains a set of rules, right? Or it might be more accurate to say that the set of rules is the conceptual space, right? If a namespace is an online space, it's, some presence on the internet where that set of rules lives in a computer interpretable form as a file or set of files, right? We'll return to online spaces in a few minutes, but first let's talk about a set of rules, right? This is the name, and I hope I'm going to pronounce this correctly, Park Geun-hye, the current president of South Korea. And I really, really hope that these characters copy and pasted correctly, because otherwise that could be quite embarrassing. Why am I putting up a Korean name on the slide? The reason is I understand from my Korean friends that Korean names of people, always have 3 syllables. And, moreover, that there are only a few hundred family names that exist in Korea. So 3 syllables, a few hundred family names, that's going to lead to a very large number of possible names, but that's likely to be a smaller set of possible names than in English. In English, a name can have as many syllables as you want, and you see names in English that are quite long. Pomerantz is no treat sometimes. I don't know how many family names exist in English-speaking countries. There must be thousands, right? That is a huge set of possible names, right? And even so, even with that large a set of possible names, we still get what are called collisions, right? Jeffrey Pomerantz is not a common name, but I know of at least one other Jeff Pomerantz out there in the world. We have a namespace collision. We both have the same name. There are other possible namespaces for names for people, right? Jesus of Nazareth is an interesting example of a particular namespace, right? What that namespace's rules are is you have a given name of a place of origin, right? According to that set of rules, my name would be Jeffrey of Boston. Right? I was not born there, but I grew up there, right? Now, name of place works okay when there's only 300 million people on the earth, which is, I looked this up, an approximate estimate for how many people were alive 2,000 years ago. It's probably not going to work so well with 7 billion people on earth. Right? Too many people named Jeffrey are going to live in Boston. Right? Another interesting example of a namespace is, the example is Björk Gudmundsdottir. Right? So what we have here is name, given name, father's name, and then relationship to father. Right? So my understanding is that Björk's father's name was Gudmundur Gunnarsson, right? So Gunnarsson, son of Gunnar, right? So this actually may be a better namespace system than name of place, because you have 3 variables instead of only 2, even if one of those variables only has 2 values, right? Son or daughter, right? When I say a better namespace system, better means fewer name collisions, right? But there's still likely to be some namespace collisions. So how do you create a namespace that prevents collisions entirely? Well, you can probably never prevent them entirely, but you can certainly do better than human names. Forgive me for using a United States-centric example here, but it's what I'm familiar with. The Social Security number in the United States is a good example here, right? The Social Security Administration of the federal government doesn't refer to a namespace for Social Security numbers, but we can think of it that way for the sake of argument, right? Because there are rules for how Social Security numbers are created, even though those rules are fairly loose, right? Social Security numbers are created as follows. First, we get a 3-digit, what's called area number, which roughly corresponds to the area of the United States where a person was born, right? In general, the lowest numbers are in the Northeast of the country and move higher the further west you go, right? It used to be that number ranges were assigned to states in the United States, but it hasn't been that way for a long time. So the middle 2 digits here are what are called a group number, which are assigned in order within areas. And then these last 4 digits here are just randomly assigned. So we have a simple set of rules, but nevertheless a set of rules for how Social Security numbers are constructed. So in the United States, because Social Security numbers are 9 digits long, we get a namespace that consists of 10 to the 9th combinations, which is 1 billion combinations. The current United States population is approximately 314 million people. So in theory, we should never have namespace collisions with Social Security numbers because the possible number of combinations of digits is so much larger than the current population, right? Every citizen of the United States has a unique Social Security number. It's a namespace, it's a much less ambiguous one than actual human names, right? Jeffrey Pomerantz is not a common name, but there is one other Jeff Pomerantz out there in the world. But I guarantee you, we have different Social Security numbers. right? We have a namespace collision in the namespace of real names, but not in the namespace of social security numbers. Another namespace that avoids collisions is physical addresses, right? Again, forgive a United States-centric example. This is the address of the White House. Replace this address with an example in whatever addressing scheme you use wherever you live. So the structure of a physical address, at least in the US, is from most to least specific, right? First you get the number on a street, then you get the street, then you get the city and the state, right? So you go from the smallest to the largest unit, and then at the end you get zip code, which is a region larger than a street but smaller than a city. So the smallest to largest scheme breaks down some there, but anyway. But this system does manage to avoid collisions, reasonably well, right? Zip codes are unique within the United States. You're not going to have more than one Pennsylvania Avenue in Washington, D.C. You're also not going to have more than one 1600 on Pennsylvania Avenue, right? So this address uniquely identifies a single building. And the important point here is uniquely identifies, right? So a namespace is a set of rules. It is a conceptual space for defining unique identifiers for objects, for entities, right? A unique identifier can be a name or it can be an address. And quite frankly, the distinction between name and address sometimes breaks down completely when you're talking about namespaces, which is why the term unique identifier is often used instead of the term name or address.